Hey besties. So go ahead and get out your notes, and this is page 4 of our notes. All right, Cavalieri's principle. Okay, so Cavalieri's principle says if two, hold on, let me resize this. If two 3D objects, so three-dimensional objects, cone, cylinder, sphere, stuff like that. If two 3D objects have the same height and the same, and we're going to need that blank too, have the same height and the same cross-sectional area at every level, then they have the same volume. All right, guys, this is really wordy. What it means is if we have two things, we can say that two shapes have the same volume, okay? We need to have the same height between our figures, and we need to establish that they have the same base, which is the same as the cross-section area. All right, we always have to check for those two pieces in order to say, yes, they will have the same volume by this principle. All right, so we don't have many proofs like how we did last year, but this will be one of our proofs for this semester in geometry, okay? We want to be able to say, yes, these two figures will have the same volume using Cavalieri's principle because they have the same height and because they have the same cross-sectional area. Okay, if one of those pieces is missing, if one of those properties is missing, then no, we cannot say they'll have the same volume. All right, so some examples here of figures that have the same height and same area. Typically, they just look like a perfect, like straight up and down 3D figure and then pushed over to the side. So here we have a straight up rectangular prism compared to a slanted rectangular prism. We have a cylinder compared to a slanted cylinder. We have another square prism compared to a slanted square prism, okay? Even the stack of pennies. We have 1 penny, 2 pennies, all neatly stacked, and then we have some that are just kind of thrown all together. All right, in each case, in each of these situations, we have to establish that this stack of pennies is the same height as this stack, that these two guys are the same height, that these two guys have the same height, etc. And then that this area of this circle matches the area of this circle. The area of this rectangle matches the area of this rectangle, okay? If we can establish those two pieces, those two properties, then yes, they will have the same volume. All right, so we're gonna jump around. I'm gonna do a couple of these problems. That way you can understand how to work them, how to see if they have the same height and volume or area, and then you can fill in the rest of your notes, all right? So for number 1, example number 1, we want to figure out which solid has more volume. So what we need to do is, again, we need to identify, do they have the same height? And do they have the same, I'm going to use base because it's the bottom of our figures in this case, and it's just easier for me to write rather than cross-sectional. But when we slice into our figures, this guy, is that area the same as this guy? Is that area the same as this guy? And then are they all the same height? All right. So let's get into finding area. All right, for this square, because this is a square, we have 4 right angles, all right, which means all three, or well, actually it's a rectangle, so it doesn't really matter. The area of a rectangle, a square is a rectangle, we have length times width, so I'm going to plug in 3 times 2, and so my area of this rectangular prism is 6 centimeters squared. Ignore what I said about it being a square prism. It's a rectangular prism. Here, my area formula is not changing. Even though it's slanted, you're still going to use the area formula base times height, or in this case, length times width, okay? So we have the base slash the length right there, and then we have the height slash the width of our square of this little cross-sectional area. And so I'm going to plug in those two pieces. We have 3 times 2 which again gives us 6 centimeters squared. So we're looking good, but we need to double check this last figure to make sure the area of this guy, this triangle, is the same as the first two areas, because if they are, then yes, we have the same height, and we can check off that they have the same base area. All right, so I'm going to check that off. The area of a triangle is given by the formula base times height divided by 2. All right, and when I'm dealing with triangles, I typically just say the bottom of it is the base, and then the vertical piece here, there's a little dotted line that's showing the vertical piece, that's your height. So in my formula, I'm going to do 6 times 2 divided by 2. 6 times 2 is 12, divided by 2 is 6 centimeters squared. So all three of these areas of the cross sections are 6. So we can say that yes, they have the same height and the same base area. And so, because of those two reasons, these solids have the same volume. All three of them have the same volume because you know we're going to ask you guys for explanations because those reasons and that one. All right? And so that's your work. You're going to have to find your area, and then you're going to have to work to solve for, not solve, but find your area, compare your heights, and then you can determine, yes, I can use Cavalieris, or no, I can't. All right? So the other two problems are pretty straightforward. I want to look at number 4 real quick, and then we're going to jump to the back side. All right? Which solid has more volume? Well, again, we need to establish that we have the same height, and we need to establish that they have the same base area. All right, so on this diagram, they both have this piece right here, both have a height of 6 inches. So we can cross off one of our properties. Now we need to know, do they have the same base area? This is where we're stuck. We don't know the area of this circle because we don't have a radius, so we can't plug it in to the area of a circle formula. And we only have the height, we don't have the length and the width of the triangle, of the square here. And so we can't plug it into the length times width formula for a rectangle. So we would be able to say that these solids have the same volume if and only if, got to be real dramatic here, their bases areas are the same. All right, so again, we need to establish that the area of this square and this circle are the same, and then yes, we could say that it's Cavalieri's principle applies here. All right, I want to take a look at one more problem, and then you guys will have the rest of your notes to figure out. Flip over your page and look at number 6, okay? Because this one is a little more error analysis. So flip over to page 5, and we're going to end on number 6 for this video. All right, so we have that Tim tried to use Cavalieri's principle to show that two figures have the same volume. You guys will have to read, so sorry about it, but suck it up. The base areas are the same. This is what Tim says. The base areas are the same, so the corresponding cross sections have the same area, so the volume must be the same. All right, but he's trying to use Cavalieri's principle in order to say that they have the same volume. All right. What was a mistake Tim made? Because Tim is not correct. It sounds good, but he's not really correct, okay? Remember, when proving Cavalieri's principle, we have to prove two things. That they have the same height, the figures have the same height. Oopsie. and that they have the same base area. So in Tim's explanation, he mentioned something about the base area. All right, they said they have the same area, and then jumped straight into, same base area. We can check that off the list. And then he jumps straight into, okay, yeah, they have the same area, so we can use Cavalier's principle. The volumes are the same. But again, you have to prove both properties. So Tim's mistake is that he did not establish they have the same height. All right, so my answer is in pink. Tim did not state that the figures are the same height. All right, that's a big old no-no when it comes to Cavalier's principle. All right, so based on that, you should be able to complete all the other problems through page 5 and the rest of page 4 from up above. So go ahead and work on that. You have my answer key for my notes that will be uploaded in the daily agenda. And once you're done with that, go ahead and head on to the assignment for the day. Have a good day, and I'll see you guys on Monday. Bye.